Good morning, good afternoon, and good evening, everyone. Dear authors and invited guests, welcome to Technical Session 9A. I'm Sanskriti Khamkar, and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026, in London, UK. This edition of the conference is being held in a hybrid mode. The physical event was held on the 24th in London, and the virtual sessions are being conducted via Zoom from 25th to 27th February 2026. I hope you find today's session engaging, informative, and insightful. In this session, we have 6 presentations. Each presenter will have 12 minutes for their presentation, followed by 3 minutes for question and answers. I will give a gentle reminder when 2 minutes remain. I request all participants to stay connected until the closing remarks. If you have any questions or updates, feel free to share them in the chat box. I'd also like to apologize in advance for any mispronunciation of names during the session. Now, before we begin, I would like to introduce our session chairs. We have Professor Yoshiko Goda, who is currently serving as a professor at Kumamoto University in Japan. She's affiliated with the Research Center for Instructional Systems and the Research and Education Institute for Semiconductors and Informatics. Her research focuses on instructional and learning design, self-regulated learning, that is SRL, and technology enhanced language learning, contributing significantly to the advancement of learner-centered and technology-driven education. Welcome, Professor Goda. Would you please like to share a few words with us?
Hello, I'm Yoshiko Goda. Thank you very much for the introduction. I'm a professor at the Kumamoto University. It's my great pleasure to serve the session chair today with Naveed Sharma. Today's session brings together a diverse and exciting set of research contributions spanning cloud adoption for SMEs, machine learning methodology, cybersecurity practice, AI governance, virtual laboratory innovation, and robotic path planning. The breadth of topics truly reflect the interdisciplinary and forward-looking spirit of this conference. I'm looking forward to all presentations, and I encourage active participation from the audience. Please feel free to post your questions in chat and raise your hand during Q&A sessions. Thank you.
Thank you, ma'am. We are also joined by Dr. Naveed Sharma, who is an associate professor in the Department of Computer Science and IT at IIS University, Jaipur, with over 19 years of teaching experience at both undergraduate and postgraduate levels. He is actively associated with more than 15 universities and academic associations for various scholarly activities. His research interests span e-commerce, cloud computing, and network security. He has published over 25 research papers in reputed international journals. Welcome, sir. Would you please like to share a few words with us?
Namaskar, everyone. Thank you so much for the nice introduction. Am I audible to all of you?
Yes, sir, you're audible.
So, welcome in the session.
Yes. Now we proceed with the presentations. First up, we have Bruno Manuel Souza de Carvalho, who is presenting a decision support system for cloud adoption by SMES, a DSR-based model.
Hello there. Thank you very much. Am I allowed to share the screen?
Yes, you may share your presentation.
Okay. Then, excuse me. Let me. Can you present itself? Can you see?
Yes, it's visible.
So, good morning. My name is Bruno Carvalho. and I'll present to you a decision support system for cloud adoption by SMEs. Cloud computing offers clear benefits, but for these SMEs, adoption is still complex and risky. They often lack structured decision frameworks and internal technical expertise. As a result, these cloud choices are frequently reactive and misaligned with business needs. Although strong adoption theories exist, practical tools for SME managers are still limited. To address this gap, it was then designed and implemented a structured, theory-informed, and vendor-neutral decision support system. The core problem is simple. SME lack a structured mechanism to guide cloud adoption decisions. Then, this research asked 3 research questions. What components are essential in a cloud DSS for these SMEs? How can it support informed evaluation? And can structured decisions improve long-term stability? Our focus is then structuring decision logic and not recommending vendors. For this, we combined 2 methodologies. The systematic literature review, the SLR, we got 29 peer-reviewed studies using the PRISMA protocol. It identified adoption determinant and theoretical foundations, which we will refer moreover, which is the TOE, TAM, and the diffusion of innovation. And the decision science research. This was used then to develop and implement the artifact. So in short, the literature defined the determinants and the DSR built the solution. The main contribution on this weighted scoring model had 3 great foundations: the TOE, the TAM, and the DOI. TOE, which is Technology Organization Environment, revolves around 3 great contexts on the company: the environment itself, the technology, and the organization. The technology acceptance model. This one focuses more on the clients, the users. The user perceived usefulness and the perceived ease of use. And then the diffusion of innovation. This one addresses the SME digital maturity and its growth. Then about the weighted scoring model itself. This one was implemented through a 55 structured business questions. It produces recommendations across 3 dimensions: the service model, which there is software as a service, platform as a service, and infrastructure as a service. The deployment model, which was public, private, and hybrid options, and the support model, which would be self-managed by itself, recurring to a third party, or the vendor managed itself. About its weighting, they are literature informed. What does this mean? It means that if there would be a strong determinant it would be given a +2 because the factor would be really critical. If there's a secondary determinant and let's say less important or less central, then it would be given a +1. This scale is intentional simple just to maintain the transparency and the usability. Giving you a practical example, one of the question asks, would automating tasks such as invoicing benefit your business? If the user answers yes, then going through the 3 foundations, from a TAM perspective, this shows a high perceived usefulness from the user. And a task like this one is from a ready-to-use application. Therefore, the software as a service would have a +2, the biggest score. From a diffusion of innovation perspective, it suggests that the company wants to grow or has a growing maturity, giving itself then a +1 on the platform as a service, which would be a bit more customizable, let's say it this way. From the TOE organizational perspective, SMEs in this context rarely need infrastructure control. So we wouldn't give anything to the infrastructure as a service, to the point. So With this, we could say that a single business answer activates multi-theoretical logic and generates a structured recommendation. With this, we tested the model with 3 SME personas. A small bakery, a very simple one, a mid-sized manufacturer, and an IT consultancy. Each of them generated distinct and all logically consistent recommendations, confirming then internal coherence. With this, we implemented the artifact. The model was implemented as a web application using a fast, scalable, and serverless architecture. As you could see, I also used Cloudflare just because of the cloud usage. Users complete the questionnaire and receive structured recommendations across the 3 dimensions. So as you can see, it goes through a consent page, company information, which was a small data extraction with anonymity. Then goes through a questionnaire, the recommendation page, and a small verification for the same. It is accessible down there if you'd like to see it at brunimesse.pt. The focus here was clarity, accessibility, and neutrality. With this, we had an exploratory pilot study of 7 people. There was 3 main key findings. The first one being that 86% of recommendations indicated software as a service dominance. The second one, that 86% as well indicated a third-party support, a great need in support above just technical choices. And the third one, the persona validation, that showed that business efficiency often outweighs technical ambition in decision outcomes. Overall, just suggests that SME prioritize operational simplicity as well and external expertise. Sorry. With this, answering the research questions I had about the first one of the how to simplify in components, we would say they would focus on 3 main components, which was service, deployment, and support, as it did on the weighting scoring model. About the alternatives, we do not advise which vendor or which choice to make, but we tend to create a clear profile of their own needs first. And third one, about the stability, there would be a good post-adoption stability ensured by making the support model as the primary decision point. Implications for practice. The DSS provides SMEs with a structured needs profile to guide discussions with providers. And for research, the findings suggests that organizational and operational factors may be influential than just purely technical ones and in the cloud adoption itself. Concluding, there was limitations, including the pilot scale. There was only a group of 7 and the lack of statistical validation of weights. Not only that, there was a sample bias because all of the 7 already used cloud itself in any means, from SaaS to IaaS. As a future work, it would include large empirical validation, probably financial modeling integration, maybe machine learning or any other LLMs, and maybe an application that would be a continuous platform. Instead of just helping in the decision, it might as well just help on the maintenance of it as well. Concluding, this research bridges theory and practice by translating established adoption frameworks into a usable decision support tool for SMEs. I think these initial results indicate a strong alignment with real business priorities and demonstrate the value of structured decision making. Thank you very much. Hello.
Hi, thank you very much for your presentation. And Can I just moderate the presentation and session, right?
Sorry?
Yeah, okay. Then do you have any questions or comments to Bruno's presentation? Yeah, while other people are thinking about a question, I would like to ask one question.
Sure.
So you organize like three personas, right?
Yeah.
Could you clarify how the three persona were constructed and validated?
Okay. So this is not wait, let me just get to the part.
Mhm.
Oh,
Yeah,
now I'm confused, sorry. So the personas weren't validating at the end. They were they were made in the beginning from the pilot of 7 that confirmed it, and also from the papers that were analyzed, because this was going to be the first comparison and the first analysis of this 55 structured business questions.
right.
We could say it has a second option because there was no empirical validation. Like there was not a big empirical validation.
Yeah, thank you. Any other questions or comments?
Yeah, I have one question.
Yes.
Am I audible? Bruno, are you getting my voice?
A bit low. Maybe it's me.
Are you getting my voice now?
Okay. Yes. Thank you.
Uh, can you more elaborate upon your work in this model?
Sorry, your mic went low again. My apologies.
Okay, go ahead. No issue. Thank you so much.
Okay, sorry.
Thank you, Mr. Bruno, Professor Yoshiko, and Dr. Namath.
Thank you. Just stop screen share. Okay.
Our next presenter is Sayatan Saha, who's presenting a self-correcting regularized risk-based positive enabling learning approach hidden under stratification.
A very good morning, good afternoon, good evening to all the attendees. Am I audible?
Yes, you're audible.
Let me share my screen. Is my screen visible?
Yes, sir, it's visible.
Okay. So myself, Shantan Shah, and I did my PhD from IIT Kharagpur, India. And today I'm going to present this paper, a self-correcting regularized risk-based positive unlevel learning approach under hidden stratification. So to introduce this problem, first let's see what is positive unlevel learning or PU learning. So it is a binary classification technique with only level positive data and unlevel data. There are vast application areas of PU learning, like in biomedical applications, we can use this PU learning in disease gene identification, protein-protein interaction, then in healthcare and computational drug discovery. There are also some business applications like developing a recommender systems and direct marketing and fraud detection. Also, there are a few applications on computer vision and text like automatic face tagging, land type classification, then document classification and website classification. So the hidden stratification is a situation where a labeled class contains multiple hidden subclasses. So when this scenario occurs, so the ML models, the machine learning models perform well on very common subclasses or dominating subclasses, but the performance may fail on the rare ones. And that's why it may lead to a misleading performance metrics and we can get a biased evaluation. So the effects of hidden stratification is we can achieve overestimation of overall model accuracy. The poor we can it may occur the poor detection of rare but critical subclasses, and it may reduce the trustworthiness and robustness of on ML systems. There are some real world scenarios where hidden stratification occurs. Like some misdiagnosis of rare disease due to hidden subgroups, failure in detecting unusual road signs or rare pedestrian behavior, and there are also some misclassification across dialects or low resource languages. So we can find there are a few shortcomings in the existing prior PU methods. Like the first one is incorporation of the positive classifier in the existing PU risk estimator. This positive classifier is basically the ratio of positive class among the unlabeled class, which is usually denoted as alpha p. Now, working with the priorly known alpha p is not very much realistic because we don't have any kind of level information in the unlabeled data. And also, if we want to estimate the alpha p, so due to some error in the estimation alpha p, it may result the performance of Q classifier may degrade. Now, the impact of, if you see the impact of hidden stratification in level positive data, so that is the performance evaluation of Q classifier during the presence of uniformly distributed hidden subclasses in level positive data, it may hamper. Also, we are very much interested to see the performance evaluation of Q classifier during the presence of non-uniformly distributed hidden subclasses in level positive data. And lastly, the performance evaluation of Q classifier during the identification of the rare subclasses in level positive data. So in all possible scenarios, all possible distributions of the hidden subclasses, we are trying to investigate what would be the impact of hidden stratification in level positive data. So that is our method that is named as PUSCRRK, that is positive unlabeled self-correcting regularized risk and K means. So firstly, here we have initially the level positive data that is denoted as XP and a set of predefined number of clusters that is K. So to identify the hidden subclasses, we will first cluster these level positive data. And based on k-means clustering, and depending on the silhouette score, based on the silhouette score, we are trying to find the correct optimal number of clusters. So from XP we can get XP hat, that is a clustered level positive data, and so that is our first step of our method. Then our next step of our PU classifier is the PU classification, where we have the unlabeled data, XU, and the clustered level positive data, that is XP hat, with all the clustered levels ZP. So, and we have the So in this Pew classification method, there are two set of modules are there. The first is potential negative sample selection. So to select the potential negative sample, we have a potential negative sampler that is denoted as H theta. Now we will first initialize this our potential negative selector, and it is the model is basically the base of the model is a pretrained REST-18 model, and top of that we will set a feedforward neural network where in the last layer we have a k star plus one number of neurons, because in the previous step we all know that we already get a k star number of clusters on the level positive data, and so the total number of, so here we will perform a multi-class classification to select the potential negative sample, and that's where the last layer will be k star plus one. Then how we will select the potential negative samples? So based on the confidence score, that is beta I, that is the output of the potential negative sampler, based on the score we will select the potential negative sample or candidate negative sample, and we will form the potential negative sample set, that is xn bar. Now in the very next step, now we have the cluster level positive data and potential negative data, and we will take this sample and we will process it through the similar kind of model that is the same as a potential negative sampler. So here also we have the pre-trained REST-18 model, and on the top of that here we have two feed-forward neural network. That is, one is omega 1 and another one is omega 2. Now the architecture of this omega 1 is exactly same as the fit for neural network that is used in the potential negative sample selection phase, and the another one that is a and that is denoted as a mu p. Here in line number 2 we can get, and the other fit for the output of the other fit for neural network, that is omega 2, that is only a single layer perceptron, where so that is the output is denoted as a kappa, and we will take the positive value of this kappa n, so that's the maximize of omega 2 phi xn comma 0. So here we are getting this two different loss, that is L plus G theta x star and L minus G theta x star. That is a loss corresponding to the samples, and we will use one regularizer that is denoted as a REG G theta x star, and we will develop. We are developing this regularized risk function, that is RPUSCRR, which is a summation of all these three components. Now coming to the details of the experiment part. So here we have performed the experiments on this 4 image data set. That is a very standard image data set: CIFAR 10, CIFAR 100, Fashion MNIST, and STL10. And for each data set, we are designing 2 different tasks, where these are the task names are mentioned in the slide. So so there are so here if you will see, because we are trying to find out the impact of the hidden stratification, so intentionally we are taking multiple classes in the positive class. Like in the CIFAR 10 one, we are taking bird class and cat class, and we will consider it as a positive class. So in the CIFAR 10 2, in the non-animal, so all the non-animal samples will form this positive class, and it is the same as the other data sets. Now, if we will see the data distribution of the level positive and unlabeled data, so we are taking 3 different alpha p value, that is a 0.8, 0.5, and 0.2. The objective is to observe the performance under a positive class dominated unlabeled set where alpha p equals to 0.8, a balanced unlabeled set, that is 0.5, and a negative class dominated unlabeled set where alpha p equals to 0.2. And for each chosen alpha p, we are taking these ratios of level positive data. For CIFAR 102, this task, we are taking two different ratio of level positive data just to investigate the performance of the PU classifier in the uniform distribution and non-uniform distribution.
Excuse me, sir.
Similarly, yes.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes
Oh.
of your presentation remain.
How much time I have?
You have 2 minutes left.
Okay. I will quickly wrap it up. So now in the result, so here we can see for all the non-uniform distribution, our method PUSCRRK is performing well compared to all the other state of the arts. But for the balanced case, that is 1:1 case, the PUSCRR that is in this method is the best model. In case of 0.5, alpha phi equals 0.5, similar kind of scenario we can see, and alpha p equals to 0.2, similar kind of scenario we can see. For 10+2 here also in uniform distribution and non-uniform distribution, our method is performing well. And this is the performance on CIFAR 100. This is the performance on FMNIST, that is a fashion MNIST. This is the worst case test accuracy, where there is accuracy on the rare subclasses. So here we can see, depending on the alpha phi value, our method is performing well throughout the alpha phi value, and the percentage is mentioned here. This is the worst case test accuracy on CIFAR 100 task, and this is the worst case test accuracy on STL10 dataset. So to conclude our work, during the imbalanced presence of the hidden subclasses, our model, that is PUSCRK, that is outperforms all the state of the art. And also during the balanced presence of the hidden subclasses in level positive data, our method and also our previous version of our method, that is PUSCRR, that is outperforms all the other state of the art. Thank you.
Thank you, Sayantan. You have given a very well presentation. Are you getting my voice?
Yes, sir.
Yes. So it's a very specific presentation on the very specific tool and topic. I have one question.
Yes, sir.
In your data set, you have
Yes,
chosen CIFAR 10 and CIFAR 100, right?
Yes, sir. Yes, sir.
So any specific criteria to selection for this data set?
Sir, in CIFAR 100, so there are the subclass levels are there are the classes and subclasses as well. So in CIFAR 100 task, we have actually in CIFAR 100 dataset we have 100 class. So among those 100 classes, there are 20 means the main class, and under each class we have 5 subclasses. So so here we are trying to the main intention of this work is trying to find the hidden stratification under the level positive data. So because in 700 the inclined the hidden subclasses are the subclasses are available in the dataset, so that's why we are taking the CIFAR 100 task.
Okay, thank you so much.
I also have a question. It seems that your method shows promise for safety critical domains such as medical imaging and also autonomous driving. What the challenges do you foresee when deploying it in a real world environment?
Okay, thank you, ma'am, for this question. So, like when So here, the main challenge is here initially that getting the fully level data is not uh, much convenient. Like here in our real world scenarios, like anywhere in medical domain or in any other domain, all the classes of interest or the leveling task, uh, we can level it like, so for example, if we are surfing the internet, so based on our browsing history we can get our search interest or the topics of our class of interest. So we don't need to level manually of all those things. Leveling is a very tedious task. So the sole purpose of positive unlevel learning is naturally whatever we have the naturally level data. So based on that and all the unlevel data, to how we can classify it in a binary way. So in medical domain and in also autonomous driving on all the other domain. So if we can get the naturally the level positive data, if we can get it, so then we can deploy this our methodology in that particular domain.
Thank you.
Okay, thank you.
Right. Thank you, Mr. Sandram, Professor Yoshiko, and Dr. Naveen. Next, we have Shegun M. Obisiasan presenting Assessing Cybersecurity Practices Among Online Shoppers Using Internet Cafes in Jebera.
Good evening and good evening to everyone. I hope am I audible?
Yes, you're audible.
Okay, let me quickly share my screen. I'll be presenting our article, which is assessing cybersecurity among online. Sorry, think like I changed that. Just give me a few seconds again. Oh. Okay, is my screen still are you seeing the screen?
Yes, it is visible.
Okay, thank you. I'm presenting our article, which is on assessing cybersecurity practices among online shoppers using internet cafe in Quebec. And the background of our study is the background of the study. That is e-commerce, South Africa e-commerce sector is fast growing to the internet usage, and online shoppers as of 2022, we have more than 27 million online shoppers on data, which is expected to increase to 37.9 million by 2027. So in Eastern Cape, where the study is conducted, and also in Quebec, so internet penetration as among the online shoppers is 55.3%, which shows that many users are accessing internet to share public cafe. So, and the problem is the growth has increased, but which has caused a cybersecurity risk, particularly for shoppers using unsecure public internet cafe, which is estimated to loss of that is 22 billion rand in South Africa rand. So the gap here is we have 52% of online shopper that lack vital cybersecurity skills, and some even ignore cybersecurity practices like creating password or using two-factor authentication when making them more unable cyber attack in public internet cafe. So there's a need for understanding the cybersecurity practices among these online shoppers using public internet cafe facility, which is a critical research questions there. So our objective is to examine cybersecurity practices among online shoppers in public internet cafe in Quebec, Instant Cape. So these are the research questions. We have the shopping frequency, which are what was the frequency of online shopping in the internet cafe. We have their perceived threat, that what were the perceived cybersecurity risk and threat and risk among online shopper. So awareness level. So what was the awareness of basic cybersecurity practices? And also we have the cybersecurity measures, which is to what extent did shopper use the cybersecurity measures even when they are aware of it. So our methodology is we adopt quantitative method, and we obtained what they call the ethical clearance, and this is a self-administered questionnaires with close-ended item. So where we distributed 100 questionnaires among shoppers across three public internet cafe in Quebec. So out of those 190 were actually completed, and the rest that were discarded because it's not properly filled, and some are filled by those that are not even shopping online. So we did the reliability test of that questionnaire, where we get the higher internal consequences, and also we use SPSS version for the analysis. So who are these online shoppers? These are young people. So we have up to 80% age from 20 to 40 years of age, with majority of them being a male and a slight of them being a female, which is 46% being a female. So talking of the educational level, we have 44% who had matric as a higher certificate, and we have less than 7% holding a master degree. So we are talking of their shopping experiences. We have more people. These online shoppers have less than 3 years of online shopping. So, and the shopping frequency, we have 60%, 61.1% of them that use internet sometimes, and we have close to 40% that frequently use public internet cafe for their online shopping. So what are their perceived threats here? We have phishing threats, which is the highest in this usually online shopper perception, what they perception, which is that they believe that most of time that they face phishing attempt when shopping on the public internet cafe, and data theft. They also frequently encounter cyber crime that targeting them to steal their customer data. So we also have the authorized sorry for that. We also have that is the unauthorized access. So they identified an identified threat of a transaction on their accounts, which means that some of them see that they are trying to like taking money from their for their account on something they don't even on transaction they did not conduct it. So talking of the cyber risk, or the risk of using internet cafe. So there is a higher cyber security risk among those shoppers using the online shoppers shopping on the internet cafe when they are shopping on the public internet cafe. So we're talking of the knowledge and action gap here. So the awareness of cybersecurity practice. So most of the online shoppers demonstrate that they have the strong awareness of cybersecurity practice. Like we can see from the data, we have like 86% say they know how to create password, close to 83% understood the importance of reviewing their bank statement. And we have close to 80% recognize need for secure website, HTTP. And we also have those that are also close to 77.8% know to use a reputable payment system. But when talk of the implementations, is the other way. There is inconsistency without the actual awareness compared to the implementation of these security measures. So we only have like 60% are always create strong password. You have less than 40% are always enable to authentication. So 67, close to 66.7% always verify platform authenticity before they shop on the public internet cafe. So nearly close to 60% remain or at least because they don't use two-factor authentication when they are shopping on internet cafe, public internet cafe. So we also did our statistic relationship, and this internet relationship um we have the go back there. We have what do you call talking of the Springer correlation test review, the positive significant association between the threat awareness and threat and perceived threat awareness of cybersecurity practices and use of cybersecurity measures. So we have the effective of cybersecurity measures and strongly that those people, online shopper that have the effectiveness of cybersecurity practice. So the song which strongly influence the use of their security measures, which in people that are so those that are understand the effective of cybersecurity, the use of that understand the effectiveness of cybersecurity practice influence their use of security measures for their safety online. So we also have the awareness and threats. So online shopper that perceive internet as a internet cafe as a place that is prone to security threat, they show strong awareness as well to cybersecurity practices. Also, we have this awareness usage. So online shopper who are aware of the basic cybersecurity and basic practices were strongly likely to use security measure well for their safety online. So, but in reality, with even with that structure, we have the awareness of what they call it. Despite that awareness of cybersecurity threats, online shoppers show strong and they demonstrate poor security practice. So knowledge alone does not really translate to their for the online safety. So so there is still a critical gap between them understanding the risk and even taking the security measures in a practical sense. So when we're talking of threats and awareness are necessary, but that is not sufficient for their protection alone when shopping in that, especially in the intensive area like public internet cafe. So this is the action. So the conclusion, the action is that the public internet cafe and then and the e-commerce platforms should educate shoppers on the adherence to the safe security practices and threat identification, such as adopting multi-factor authentication like two-factor authentication or increase online protection. So there's also a need for them to also verify if there is a secure logo. I also need to do for a platform what they call legitimacy to know that is it a right platform they are shopping from. So there's a need for them to also advocate for the users, so internet shoppers to also create strong password for each account they are using. So a strong behavioral adherence and support system level intervention are also essential so that this online shopper when they shop online, they have understanding of why importance for them to use to follow cybersecurity practices, especially in a very intense environment like that of internet cafe. So the further study here that should be conducted in other provinces of South Africa here and also in Eastern Cape. Also, so which one we can relate so we can now relate with different other environments such as a private or public internet cafe. So study can also be compare internet user with those that shop on those that with those that shop on that with home-based users with also with the also online and what do you call it the people that use the public internet cafe to see to highlight their contextual differences. So uh and that is the end. Thank you.
Sagun, are you getting my voice?
Yes, I can hear you, sir.
In your conclusion, you have mentioned few actions. So, is there any specific unique action which you have introduced as a new action or some guidelines?
Thank you. Thank you for that question, sir. The new because this thing the new action that was generated in the because this one is a quantitative aspect of the because the whole study is already this a mixed method. So among the new action that was generated is the e-commerce platform should also incorporate a multi-factor authentication to their platform because most of them, according to the study, most of them does not have it. So, and another thing that we also discovered that is that they should also what's it called? They should also have a verification link that when somebody creates an account on their platform, they can send them a link for them to verify that okay, this is a platform. So the people that they'll get a link in their email for them to log to click on that link to continue to complete their account for them to be able to show that the site they are using is a credible site. Another thing we also talk about, we talk of the OTP as well. That some platforms too can also, can also incorporate OTP. That people can also receive OTP on their phone, their devices when they are also logging into their account. So those are some of and we also recommended password and management, which are part of a study that is not mentioned on here. So thank you, sir.
Okay, thank you. Thank you so much. Any other questions from the audience?
Yeah, I also have a question. With a sample of 90 respondents from 3 cafes, to what extent do you believe your findings are generalized to other regions or countries? Do you plan to conduct larger scale or intervention-based studies?
Thank you for that, Prof. Yeah, although I would say because although the information was not mentioned, but one of the limitations for that study is that the other provinces that other provinces can also extend the data set because there is a limitation for 90% 90 questionnaires. But since it's a mixed method, so one of the other thing that was mentioned on that method, on the mixed method is that because the quantitative also and give you details of how other provinces can also incorporate extend the questionnaires, the study further. So those are part of what was also mentioned in the entire thesis himself. So, and to also add to that, it also we also stated that the that other provinces or maybe even in here in Port Elizabeth that they can also extended they can also have follow the same method of the project the questionnaire and also the method that was incorporated in the study at a general scale for them to also get more insight, information, and also to get more access to what people's online shoppers perception and the understanding of the basic cybersecurity practices. So those are some of all those things that we also included in the study, but it's not mentioned here. Thank you, ma'am.
Yeah, thank you very much.
Yes.
Thank you, Mr. Shakun, Dr. Navneet, and Professor Yoshiko for the discussion. Next, we have Gilma dos Santos Marquez presenting GA, a general AI governance model for the responsible adoption of AI and generative AI.
May I share the slides?
Yes, please.
Where is it? Where's the share button? Oh, here. Okay. Is it audible?
Yes, you're audible.
Okay. I'm João Gondim. I'm presenting on behalf of Gilmar and Professor Edna Canedo. This is a paper, GAIM, a general AI governance model for the responsible adoption of AI and generative AI. Okay. That was a title. As a subtitle, you could say that the idea is integrating risk management and evidence for trustworthy AI. Those are the authors. We are all from the University of Brasília, Brazil. And the idea here is to introduce GAIM, which we propose as a sector-agnostic, risk-based, and evidence-oriented AI governance model. As for motivation, for really introducing the GAIM, okay, we have this rapid AI diffusion and emerging risks. So AI systems are rapidly integrating across public and private sectors, finance, health care, education, generative AI, okay? And it accelerates this trend, offering powerful capabilities. But on the other hand, we have these social technical risks like bias, privacy violations, security weakness, opacity, hallucination in general AI, which keep on growing. We also have this that the institutional responses haven't really matched the speed that AI has been growing and being adopted. And that leads to a gap between the technological capabilities and the societal expectations. If we take a look at the landscape of AI governance, what have we got? If we look at the global regulatory context, we have EU with its AI Act, which is a central venture for policy calibrating obligations by risk level, especially for high-risk systems. We have NIST AI Risk Management Framework, which structures efforts into govern, map, measure, and manage functions. We have these 4 functions, emphasizing evidence-based risk management. We have also ISO IEC 42001 and 23894, establishing a certifiable AI management system and providing guidance for AI risk management. And we also have the context of the regulations for data protection. We have the European GDPR, and here in Brazil we have LGPD, which articulate core principles associated with this data protection. In fact, lawfulness, purpose, limitation, transparency, accountability. But there are some challenges with generative AI, like specific issues like bibliographic hallucination, overconfidence in plausible but incorrect outputs, and the need for verifiable sourcing. Then GAIM is structured in 5 integrated layers. So there's this first layer of principles and policies involving ethics, fairness, privacy, security, proportionality, and risk appetite. There are the roles and responsibilities, forms of an AI board committee, product and business, data and engineering, privacy and legal, security, MRM, internal audit. Okay, all these functions and roles play around. There is also the evidence and transparency. Model cards, the instruments, the tools, model cards, data sheets, decision logs, audit trail, change records, all as a repertoire of methods and techniques to be used. And there's this controlled life cycle of the ideation, data, development, evaluation, development, monitoring, and finally the retirement. All this coordinated with metrics and continuous improvement. So we have metrics for effectiveness, error cost, fairness, privacy, robustness, operational performance, and the SLOs. Um, if we dive in the control life cycle and the gates, we have this ideation and scoping, the gate 0, G0. The idea is to define objectives, stakeholders, harms, benefits, and the lawful basis and the risk appetite. So it's the basic definition step. Then we have the data in gate 1, G1, cataloging, quality, minimization, DPIA, secure sharing, all these relevant points. Then we have the development with the reproducible pipelines, versioning, fairness, assessment, robustness, privacy leakage tests, and the measures to carry on with that. There's the whole set of evaluation techniques in gate G3. So contextual metrics are associated, acceptance thresholds, independent validation, and the MRM sign-off included. Then we go to the development, as per se, and of the solutions. And we have these concerns about environment segregation, input and output guardrails, human override, and change management. And then post-deployment, we have this monitoring and change with drift monitors, service health monitoring, user feedback, periodic revalidation, and audits. As for the specific generative AI module, there are some identifiable risks which have to be addressed. So regarding prompt and content management, the cataloging, versioning, PII exclusion policies, grounding on authoritative data sources, verification, hallucination control, retrieval argument, RAGs, retrieval augmented generation, citation requirements, automated fact checking, and also the need for human review. As for security and abuse resistance, this module specifies the need for defenses against prompt injection, tool abuse, data exfiltration, content policy enforcement. And regarding privacy and compliance, there's this no-train processing for sensitive data, and minimization in logs, retention, DPIA for high-risk use cases. Okay, and the idea is that this apparatus plugs into the core GAIM life cycle according to the gates G0 to G5 and the evidence set. As for the GIM control metrics, there's this bridging, this moving bridging standards. So the idea is to have this interoperability, so the controls to be implemented are to be cross-referenced to major frameworks. And for example, some examples of control areas in bias fairness, cohort tests, equalized odds, privacy, data minimization, PII blocking, DPIA, for the hallucination problems, RAG, factuality checks, human review, data and concept drift, PSI, KS monitors, drift alerts, for security and abuse, red teaming, including prompt injection and environment segregation. For accountability, model data cards and decision logs, and operational quality, all linked to SLOs and champion challenger approach. So we have this framework alignment, which comes from the
Excuse me,
original
sir.
motivation. Yes, please.
Sorry to interrupt you. This is a gentle reminder of 2 minutes.
Sorry, I couldn't get it.
Am I audible now?
Yeah.
Okay. Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for the presentation.
Okay, thank you. I'll carry on. Thanks. So in terms of operationalization, we have this control risk evidence. So evidence comes as a control. It's a central design choice, treating evidence as a control on its own, and not really some part of the administrative apparatus. We have these living artifacts in terms of risk registers, DPIA, data sheets, and all the rest. All these maintained and versioned access controlled artifacts with retention policies. The benefits: it enables traceability, accelerates internal assurance, strengthens external defensibility in reviews and audits. And we have this capability maturity roadmap, going from level 1, initial, basically inventory, ad hoc approval, minimal documentation, then manage the standardized lifecycle gates from G0 to G4, defined roles and initial data sets. Level 3, that is defined, so the full G0, G5 with clear criteria, complete data sheets, and a semi-annual red teaming implemented. Then comes the quantitative, with all the SLAs for quality and security automated, with periodic revalidation, leakage metrics. And then comes optimization through continuous improvement and privacy by design, casual testing, all the rest. This guarantees also the alignment with all those the regulatory framework previously mentioned. And in terms of key strengths, we have some reproducible program design, which we expect to get that. Coupling innovation with accountability. We have this layered architecture with clear RACI roles. This translates into high-level aspirations. We translate high-level aspirations into audible, predictable routines. This addresses Gen AI failure modes, mainly hallucination prompt injection, beyond model-only evaluations. And the limitations, this sectorial heterogeneity. So control thresholds must be calibrated accordingly. That's the implementation cost, significant for small organizations, but in potentially requiring shared services. There are some conflicting metrics which might lead to trade-offs. For example, privacy versus observability, fairness versus utility, and so on, and some social technical aspect, so that success depends on leadership commitment, role clarity, and incentives. And concluding, we have that GAIM provides a general sector agnostic model for AI and Gen AI governance. We have the integrated roles, lifecycle controls, measurable metrics, and auditable evidence. It's anchored in widely accepted references and enables organizations to scale responsible AI effectively and defensively. As for future work, empirical evaluation through multi-organization field studies to
Please
quantify the
conclude your
relationship,
work.
governance, and
And
maturity, and the creation of a repository for an advice model. Thank you, and sorry for taking too much time. Thank you.
Do we have time for question and answers?
Yes, we do have time for question and
Oh, okay.
answers. 3 minutes.
I have one question. So you told that the GAIM integrates established framework such as NIST, NIST, AI, RMF, and ISO EC. What would you consider the key added value or novelty of GAIM compared to these existing frameworks?
Um, uh, f- uh, I'll risk an answer. I think that the best person to answer this question would be Professor Edna Canedo. But as for added value, let's put it like that, is the idea of I wouldn't say integrating, but building a governance model that is consistent with all these regulations, so that I wouldn't say that it tries to amalgamate all of them, but to be consistent with them and to resolve any possible conflicts, or the possible conflicts that might arise by trying to merge into this integration. So you would have something. If we look at these regulations, they tend to focus on different aspects, and in terms of not just regulation but also modeling. And here there's this I wouldn't say synthetic, but almost like synoptical approach to this question of governance in the context of Gen AI.
Thank you.
Thank you for the question.
Thank you. Now
Thank
we have
you.
Luisa Fernanda Hernandez Gallego presenting Interactive Virtual Laboratory of X-ray Diffraction, that is XRD, as a pedagogical strategy for the teaching materials in engineering.
Thank you. May I share my screen? So, can you see my screen?
Yes, it's visible.
Okay. So, good morning. Today I'm going to present Interactive Virtual Laboratory of X-ray Diffraction, XRD, as a pedagogical strategy of the teaching of materials in engineering. This research was conducted by Virtual Environment Team, which is made of a pool of professors from Institución Universitaria Pascual Bravo. Those professors are Jorge Andrés, me, Luisa Fernanda, Professor Andrés, and Professor Lady. So the context of our project is based on a structural characterization that plays a fundamental role in engineering education, as it enables the understanding of material behavior at the microscopic and crystalline levels. Among the available techniques, X-ray diffraction is one of the most important for analyzing crystalline structures. The challenges that we face is, despite its relevance, access to XRD equipment in educational institutions is often limited due high acquisition and maintaining costs, technical complexity, and strict safety protocols. These limitations reduce opportunities for hands-on experimentation and create a gap between theoretical instruction and practical understanding. The proposal and our purpose is design of an interactive virtual XRD laboratory to support the teaching of structural characterization. This purpose allows to simulate a real experiment process, safe and repeatable learning environment and straining theory practice integration. So we follow a qualitative approach within the research creation framework and integrating a theoretical reflection and project-based practice. We follow Bruno Munari's design method, which we adopt, structuring the design process through stages of analysis, conceptualization, development, and verification. So the virtual environment development was made on Unity program, which allow students and teachers to modeling crystalline structure, interactive educational interface, and real-time parameter manipulation. Also, an immediate feedback. In our results, we find that expanded and access to practical experimentation, a real-time visualization of diffraction processes. We also strengthened autonomous learning in our students community. Also, we complement the physical laboratories with a virtual laboratory. So this is the design we made, the team we made, and it helps to students practice in real time and manipulate scores and be with the teachers. So in our conclusions, we found that the laboratory is an effective pedagogical strategy which help us to expand access to material structural characterization processes in educational context when we have a limit infrastructure. The integration of visualization, simulation, and interactivity supports the understanding of complex concepts. Also, strengthens autonomous learning. And although it does not replace the physical laboratory, the virtual environment helps to traditional teaching and shows some potential to transfer and scalability to another context and knowledge in the institution. Finally, I want to take a moment to show you the laboratory in a short video. As you can see, we can manipulate anything about the laboratory, and we can study the crystalline structures. This is the X-ray diffraction machine. We simulate the transformation of the material into a structure, a molecular structure. So we can visually make a visualization of these structures. Then we proceed to analyze the structures, and it's like gamified experience for students, which they can modify any scores and do all the analysis. Well, I'm going to stop the video. And I would like to thank you all for listening.
Thank you so much.
Dr. Shani, Professor Yoshifu, do you have any questions?
Yeah, and then I will go first. I wonder, how did you evaluate the learning effectiveness of the virtual XRD laboratory compared to the traditional physical lab experiences? Did you conduct any quantitative assessment of learning outcomes?
Actually, in Pascual Bravo, we have the X-ray machine and all the laboratory. However, our community is a really large one, so not all the students are available to make some practices in this laboratory to improve the learning and make better the experience in the institution. We made this laboratory so all community can connect and make a practice, even if they cannot access to the physical laboratory. This is an improvement, and this could help another institution to replicable this type of laboratory. It helps and enables institution with high cost and all the space management.
Thank you.
Thank you.
Dr. Shani, do you have any questions?
No, no questions from my side.
Thank you, Ms. Louise and Professor Yoshifu.
Thank you.
Now we have Aris Ghazi Abdul Shahid presenting path planning of a mobile robot by improving Dijkstra's algorithm in a complex environment.
Hi, can you hear me?
Yes, you're audible.
Okay, I will share my screen.
Yes.
Is it clear?
Yes, it's visible.
Okay, I will start. Path planning of mobile robot by improving Dijkstra algorithm in a complex environment by Arish Ghazi Abdi Shahid, Department of Mechanical Engineering Techniques, Al Furat Al Awsat Technical University, Iraq. Mobile robots are widely used in too many applications, include industry, healthcare, military, service robot, and many other applications. The problems or the main challenging of mobile robot include perception, localization, motion control, and path planning. But the most crucial problem is the path planning. Path planning is the path should be drawn for mobile robot between 2 points, the start point and the goal. If the robot navigation or exploring a very complex environment, it may suffer from collision risks, sharp turns, unsafe proximity to obstacles, poor motion visibility. So the goal of presented Dijkstra algorithm or enhanced Dijkstra algorithm is to present a safe, collision-free path that can enhance and make applied in real application. There is a lot of methods that presented to try to solve this problem of path planning. The main method or algorithm is a classical Dijkstra algorithm. The Dijkstra algorithm actually succeed in generate optimal path, but the problem there is no safety margin. There is no safety clearance. The path generated will be so close to the boundary of obstacle that may cause collision, or the risks of make collision will be very high. The other algorithm is I+ algorithm, which is improved algorithm from Dijkstra. And the problem of this algorithm that the robot make during moving his path many turns and inflection points that make it very difficult to apply in real world. And the other method is genetic algorithm. Genetic algorithm depend on generating path based on mutation or crossover, which generate a lot of or new paths in every generation. This method required heavy computation and are unsuitable for real-world navigation because of long time take to make its computation. The other method is colony algorithm, which is imitating for ant behavior. The problem of this algorithm that slowly and require many iterations before a stable path is obtained. There is a lot of method, but each method have a problem either in the time running or in the distance, or it just apply it mathematically, not in practical work. The contribution of this research, a proposed enhanced Dijkstra algorithm or enhanced path planning depend on Dijkstra algorithm that adds safety zone around obstacle to prevent collision, generate valid navigation not automatically because it depends on a grid map, prevent collision during graph constructions, produce shorter and safer path, and the validate of this method will be using MATLAB simulation. The algorithm aims to map the environment, identify valid nodes for movement, create an agency matrix, and then find the optimal route using improved Dijkstra algorithm. At first, two nodes will be initialized, which is define the start and goal point. Then the model obstacle will be a regular shape like rectangle, circle, triangle, create safety zone around the obstacle, the boundary of the obstacle, generate candidate nodes, remove invalid nodes, build agency matrix, then apply Dijkstra algorithm or enhance, improve Dijkstra algorithm. The difference between two methods, classical Dijkstra algorithm and the improved Dijkstra algorithm, is the type of node. There's two types of node. The validate nodes, which consist of three types: start point, goal point, and opposite corner of safety zone, because all the validate node will be only on the boundaries of obstacle, and the invalid nodes removed if the nodes will be inside obstacle or inside safety zone. The graph constructions between nodes is tested against obstacle using line rectangle intersections check. If the collision occur, the nodes will be either inside obstacle or inside the safety zone, so the edge rejected. But the result will be safe connectivity graph. And then the line between 2 points will drawing use this equation, the difference between 2 points, which is computed and designed as the weight of the edge between them. The simulation held in environment consists of 8 obstacles, rectangle obstacle. The the obstacle shows with the blue colors. The safety zone or the boundaries around the obstacle shows with yellow color. Then the nodes separated around the corner, only the corner of the obstacle. Then here in this 4 simulations, the start point is fixed while the goals point varied in its location to show the validity of the distance. And each time the location of the goal changed, the mobile robot succeed in achieve a safe, short path between obstacles. The other simulation, we try to make the environment more complex by adding another shape of obstacles like circle, triangle, and here the goal position is fixed while the start point is changed during the simulation to show also the validity of this method by achieving a successful path and short path. The last simulation is a comparison between Dijkstra path algorithm, the original one, and the improved path. The classical Dijkstra algorithm shows with a path with the blue colors. As you see, the grid, this Dijkstra algorithm is applied in a grid map, and there is a lot of nodes that the mobile robot should calculate and should and then it find the short path, and the path you will find it filled with many turns and curves is like a zigzag. While the improved Dijkstra algorithm is shows in the another simulation with red color, show that there is the number of nodes reduce a lot. It just separated around the boundaries, the yellow boundaries. So the mobile robot or this method does not have to compute a lot of nodes to get or to find the short path. So as we see from the table, there is a huge reductions in the path lengths, around 12%. And for the turning point in the classical Dijkstra algorithm, the reduction of turning point reduced to 90-30%. And the running time, the improved path succeed in achieving or reduction the running time to 51%. And this is, of course, a huge improvement from the classical method. The improved path finding algorithm based on Dijkstra algorithm with enhancement includes first creating safe zone around obstacle to prevent collision and reducing the number of nodes, a huge reduction in the number of nodes, and that lead to a huge reduction in turning point. So the path of the mobile robot will be in straight line instead of moving in a zigzag or too many turns or inflection. This is achieved by strategical placing a limited number of nodes along the boundaries of the safety zone. This approach effectively reduces the size of the node network and significantly decreases the computation time required to find the optimal path. For the future work, could be developed for use in a dynamical environment instead of statical environment, and also increase the number of robots to be multi-robot control. Thank you.
Thank you for the presentation. I have one question.
Yes.
In the approach, safety zones are created around obstacles.
Yes.
How did you determine their shapes and sizes, and how sensitive is the path performance to these parameters?
The shape of the surrounding boundaries or safety zone will be the same shape of the obstacle. If it's rectangle, it will be rectangle. Circle will be rectangle. A circle, sorry. So the distance will be larger than the mobile robot diameter to prevent the collision.
Thank you.
Thank you.
No question from my side. Thank you.
Thank you. I'd sincerely like to thank all the authors for the excellent presentations and valuable contributions to this session. I also extend my gratitude to all participants for being a part of this international conference. I hope this session was informative and insightful. On behalf of the ICICT team, thank you for your continued support during the 11th edition of ICICT, as well as all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication is expected to be available within 7 to 8 months. We kindly request your cooperation with the ICICT 2026 team during this process. I'd also like to thank our session chairs, Dr. Navneet Sharma and Professor Rishika Goda, for effectively chairing the session. We now present a token of our appreciation on behalf of the ICICT Team 2026 and GR Scholars. Ma'am and sir, do you have any closing remarks?
Thank you very much. Thank you very much to all the presenters for your engaging and thoughtful, provoking contributions. What I found particularly interesting was how each study applied ICT, not only a technical tool, but as a means to address broader organizational, social, educational, operational challenges. I would like to sincerely thank all the authors for sharing their value work, and also my co-session chair and the moderator for their support in running this session smoothly. Thank you very much.
Thank you.
Congratulations to all the participants. They have presented very wonderful session and wonderful presentations. All the best for their future endeavors. And I would like to thank all the organizing team for organizing such a wonderful conference. And also congratulations to GR Foundation team for the successful conduction and successful presentations and participations. Thank you so much.
Thank you for your kind words, sir. Before concluding, I'd like to request everyone to please turn on their cameras so that we can have a quick snapshot of the session. Thank you everyone for joining us today. Have a great day.
Thank you.